the next presentation is by Karan Vahi from ISI, and he's going to be talking about the Pegasus workflow management system.
Sure. I think that's all. So, some logistics before we start. So, for 2 days we've been talking about the USB stick. Now's the time to use it. I will walk you through how to set up the VM in VirtualBox. But if you're not copied the zip file from the USB stick and unzipped it on the disk on your laptop, now is the time to do so. If you're wondering how I got to this link about setting up the VM using VirtualBox, if you go to the main software Carpentry website for today, there's a reference guide at the bottom. Click on VirtualBox, and that sort of walks you through how to install and set up the VM which we'll be using for exercises. So before we start, I want to spend about 10 to 15 minutes giving you an overview on workflows and what does Pegasus do. So it's a short presentation on scientific workflows and Pegasus. I'm Karan Vahi. I worked in Science Automation Technologies group at USC Information Sciences Institute. How many of you have heard about Information Sciences Institute and that it's a part of USC? Okay, fair enough. So we are not on main campus, neither we are on in the Cape campus, but we are based in Marina Del Rey. It's a research organization that is under USC Veterinary School of Engineering. Its claim to fame is the birthplace of the internet, in case you guys do not know about it. We have about 350 full-time staff. The main campus is in Marina Del Rey. There's a satellite campus in Virginia. And, the ISI itself has a lot of research areas where the faculty work in, ranging from advanced electronics, computational systems and technologies, informatics, grid computing, HPC, intelligent systems, artificial intelligence, or natural language processing. I am part of the Science Automation Technology group, which is headed by Eva, who's organized the workshop here. What our group does is we develop tools and techniques that automate the computational processes that you try and do every day in your scientific work life. Primarily, we release a scientific workflow management system called Pegasus that allows users to run workflows on a variety of different infrastructures. And our aim is to show you one way how to use Pegasus to eventually run your pipelines on HPCs. Our group usually works very closely with users to solve their computational problems. We have some funding to actually do one-to-one interactions with the users. So if you have a problem that you think can be solved by workflows and Pegasus, we are there to help you. We do have existing close collaboration with groups both at UPC campus and at Tech School. On the UPC campus, we work with the Southern California Earthquake Center in the Earth Sciences Department. Computational biology and bioinformatics, that's Ting Chen's group in CMP. And then Jim Knowles' group and Tech. We have a longish URL for him. Google would be a better way to go about it. So right now USC is here, and whereas ISI is in Marina Del Rey, that's next to Venice Beach and just before LAX. So we're not that far off, and there are shuttles that go from USC and Tech to ISI. So even though we are not that close geographically, we are there to help. So what are scientific workflows? Scientific workflows, they capture individual data transformation and analysis steps. You have large monolithic applications that can be broken down to smaller jobs. These smaller jobs can be independent, or they can be a sequence of steps that needs to be done. And you can have control flow or data flow dependencies in between them. By a data flow dependency, we mean that a job in your pipeline generates some output that a job downstream requires. So there's an edge in between those jobs, and there's a data flow dependency. It's usually expressed as a directed acyclic graph of tasks. If you have your application modeled as a work, you have advantages of scaling up execution over computational resources. You can generate a workflow which is small enough to run on a laptop, and then you can generate a workflow for your domain which is large, which requires HPCC or multiple clusters. Workflows in themselves, they provide means for automating your work. So it's one step further than writing shell scripts. And it fosters collaborations. Depending upon how you specify your workflows, the specification of the workflow becomes a means for you to share your computation or describe the recipe of your computation to your co-scientists or co-workers. Workflows can be simple. They don't need to be complicated. Let's say you have a bag of jobs that you need to run on HPCC. That is a work. So what they are dependency. A single job can also be built. Or, they can be really complicated, like the RNA-seq pipeline, which we will do after this session, where we try to run this pipeline, the VM which we have got. So, in these complicated pipelines, what you'll notice is that the underlying structure is identified by a directed acyclic graph. Usually, scientific workflows don't have, so the loops are already on. So the conditionals are not present, but still you can do a lot. So why do we need to think about workflow? You have a computation that needs to be done. You can do it as a shell script, you can do as a scientific flow, but you will be asking yourself the same questions. First, how do you manage data for your pipeline? How would you ship in the data required for your pipelines to the HPCC? Are you going to rsync or manually copy it over? Are you going to use different protocols like FTP, or let's say someday you're running your computations in the cloud, then you want to ship in data to the Amazon object storage. All these are concerns which you will come across. You have a pipeline that you're trying to run, and it's a large sequence of jobs. You need to monitor and debug your model. So one way to debug stuff is what John said, by logging into the individual worker nodes, where you're trying to figure out where is the job running, what's the STD out, and try to figure out what to it. Or you can sort of do it in an automated way by just looking at the directory on your submit host or on your laptop to figure out what went wrong. In general, like if you have a big pipeline, then you need to correlate data across lots of log files. You need to know what host a job ran on, what directory a job ran on. For example, if you're trying to run on the shared file system that HPCC. And you may realize that you might want to restructure your pipelines for improved performance, because John mentioned there are queuing wait times when you submit jobs to the PBS cluster. So if you have lots of short-running jobs, you don't really want to run one short job after the other, but instead have a way of clustering them together and submitting them as one big job. So Pegasus is a workflow management system that tries to address the concerns which I mentioned earlier. It's as a project, a collaboration between USC and the founder team at the University of Wisconsin-Madison. And what it does is it maps a resource-independent description of your computation to various resources. So when you describe a workflow to Pegasus, you describe it in a portable manner which is not bound to a particular computational resource where you're trying to run. So the description itself is shareable. You can take the same description and run it on a different cluster or run it on your desktop. It's used by a fair number of applications in a variety of domains, ranging from astronomy, earthquake science, to bioinformatics. The workflow system itself provides reliability. You can retry computations point of failure. You can do automatic retries in case of failures to account for jobs the nodes going down random. We provide scalability. We can handle large data sets and computations. Users have run workflows up to 1 million in size. What Pegasus really does well is it automatically infers what data needs to be transferred, where it needs to be transferred. It restructures the workflow for performance. And it also captures a lot of provenance information, which allows you to debug your workflows or figure out what went wrong. And you can use that to run it on a variety of distributed infrastructure like your desktop, campus cluster, grids, or clouds. Here's a higher level schematic of how Pegasus fits into the larger scheme of the cyber infrastructure stack. So we have Pegasus here, which sits on a submit node, which can be a desktop in your organization or in your center. And you interface with Pegasus either using an API interface So using an API interface, or you can build custom portals like what we are trying to do with RNSE for some of the other bio projects, or even, like grid specific Hub Zero infrastructures which allow you to compose workflows and submit them. So using Pegasus, then when you need to run the workflows, you have an option of running it on a variety of resources like campus clusters or HPCC local cluster, or within US there is a grid of computational clusters known as Open Science Grid or XC. You can run on them, or you can even run on the cloud in the cloud environments. So I mentioned that Pegasus itself takes in this description, which is a high-level description of your computation. It only identifies the computation devoid of any resource descriptions or data. So, and we'll go more deeper into this a bit later on, but what that means is, with Pegasus, you just specify your jobs by logical identifiers. So you'll say that I have a bowtie job to run, but you won't specify where is bowtie installed on a particular cluster. That's decoupled from your workflow specification. Similarly, when you say that it requires a FastQ file or it needs to generate an index file, you will refer to it with the logical identifier that this is the base name of the file it generates. You won't specify the full path of where the output will be generated. You let Pegasus handle that. So you can think of Pegasus as a workflow compiler. In this case, our target is Ponder, Diamond, DAGs, and submit files, which for the time being you don't need to worry about. And as the process of this compiling this workflow, we transform the workflow for performance and reliability. We'll automatically locate physical locations for both workflow components and data and collect some problems. So when you've described your workflow in some syntax to Pegasus, And now Pegasus needs to figure out how to run it. So it needs to look up and discover the data, the executables, and your target resource environment. So for each of these discovery mechanisms, Pegasus interfaces with information catalogs, which in case of data, we call them as a replica catalog. It says that a data set with this identifier resides at this location. It does not have to be a location on your execute machine, but a server accessible location so that Pegasus can transfer the data when the job starts. Similarly, for executables, we just need to know where the executables are installed. Don't necessarily to describe it in your input description. So we can also automatically stage the executables for, let's say, shell scripts or statically filed executables. Then we don't even require users to install them themselves. They are treated like any other input data for the workflow and deployed on demand. And finally, you want to know about the site layout. So, for example, in the case of HPCC cluster, you want to know what the staging area is, what is the scratch area, what is the storage, where can you run your jobs, and where it can permanently store the outputs. So, how does Pegasus achieve that? So let's say we have a simple hello world workflow that you want to run on a particular cluster. It takes in one input file, which we call f.a, generates an intermediate file, and then the world program takes that and generates a f.c. So this abstract workflow or the input description for Pegasus does not specify where to get the data from or where your executables are installed. You pass this input description to Pegasus, and what Pegasus will do is it will annotate the workflow with additional nodes so that the data gets shipped in before the jobs get started. It will create a directory where the whole workflow can run in, so you can share data across the jobs, which is what the staging area that John referred to in his talk was. And once the jobs complete, you can stage out the data automatically to where you want the data. So you want to do your computations on HPCC, but maybe push the outputs on local desktop or a machine in your department. So this abstraction, the notion of abstraction provides us ease of use. As a user, you don't need to worry about these details, about where the job will run, how to ship in the data. Pegasus will take care of it. The description itself is portable, that if you want to describe what your Hello World program looks like, you're going to share with users this description, not this description, which is specific to where you executed an instance of this workflow. And lastly, it gives opportunities for optimization and fault tolerance, restructuring the workflow, or doing automatically fault recovery by retrying jobs in case of failures. So I'll end up with, so in general, what does Pegasus provide an application? What's the use of an application to describe your computations as a workflow in a Pegasus format? First of all, it gives you portability. It takes the headache out of data management from your hands. Pegasus does the data management for you automatically. It can reason about, let's say, if you have multiple files for the same data set present, it will try to symlink against existing files of a particular machine. It can improve the performance of your pipeline by clustering short-running jobs together, or it can clean up data sets which are no longer required. We gather a lot of provenance information, which right now you all do probably individually in your own way, trying to figure out, I need to know how my job failed. So you'll have echo host name in your scripts, echo PWD, figure out what the working directory was, and some markers. We sort of do it structured, automated way, which is not dependent upon how the application gets. We provide a series of reliability and debugging tools that can allow you to figure out what went wrong with your application. And finally, it allows you to scale both in terms of the size of the workflow that can be run, the resources that So now we will get to the hands-on part of the tutorial where we just run a simple pipeline to Pegasus. I'll walk you through how to describe a workflow, a simple diamond workflow to Pegasus, set up the catalogs, and run it. At this point, I would want to move to the VirtualBox session. So just wanted to confirm, did anybody have any problem in unzipping the VM?
I didn't have the space on the live.
Okay. Well, I guess the only suggestion for you I have is you'll have to try it doing the exercise later.
The live CD? Yeah, and I can. Well, I tried on this. Well, I'm just so tempted.
I'm sorry?
I just want a Linux machine. That's all I want. All I want is just my own. I might get a. I might. Mac someday. I just can't.
So what are the other? We almost got there.
So it really depends upon your domain. Like in biology, Galaxy is being used, which provides a GUI interface to compose workflows. But again, like they don't have the scalability in terms of provides you a GUI to compose a workflow, but then you can't use a GUI to create really large files. So it really depends. But there are other systems, running some other systems like the one down, the load, and okay.
Yeah. So I'm running from a live so
No. It's an open source product. In fact, yeah. Like if you go to the Pegasus website, you can download it. The releases are made available as an RPM package or a dev package or a binary. In fact, most of our users are actually non-USC users right now, and that's something which we are trying to correct.
You have all the space here. There's all the space.
I tried this.
So,
That's hard.
so we have the instructions of installing the work. So has everybody downloaded and installed VirtualBox?
I tried this. Bro.
All right. So then,
And then when I thought, okay, I'll put it on my desktop. I see it.
so I just started the VirtualBox instance on my machine, and I'm going to walk you through how to set up the VM. It's going to follow pretty much the nodes which we have on. So he said, it's a new VM that we are trying to configure. Let's call it RNSC, because the same VM will be used for the RNSC pipeline later on. The type is Linux. It's a Linux-based VM. Please ensure that it is Red Hat 64-bit. You select that. That's important. Otherwise, the VM would not direct you.
So I'm allowed to.
This is asking how much memory do you want to allocate to the VM. We can stick with the default, which is 512 or half gigabytes. So we need to attach a hard drive to a VM, and that's where that zip folder comes into the picture. So I'm going to select here is use an existing virtual hard drive. So the zip file gets unzipped as a VM folder, which is what I am in right now. And I'm going to select the Pegasus tutorial VM with PO as the main disk attachment. Once we have that selected, we need to create. So we have created the base settings, but we still need to attach one more disk to the VM. So what I'll do is I'll click on the RNA-seq setting here and go to the settings tab. And there in storage, I will attach another disk to my VM. The way I do it is, if I click here, this is a link to click to add a hard disk. Click on it, choose existing disk, and then we select the RNA-seq partition. I'm sorry? Yeah, sure. So to the storage part, and there under the controller SATA, you can click on add a hard disk. If you right click on the SATA controller, it will give you an option to add hard disk. So I did add hard disk. Then I opted to choose an existing disk since we already provided that disk. And I selected the RNA-seq.vmt file. And once this is configured, we can click on start and the VM should start up.
Where is that part?
It's in the same folder. In the VM folder, like when you unzip the zip file, it created a VM folder. In that, there is this RNA-seq.vmt file. So there is a VM folder created when you unzip the file, right? So in that there is a software-carpentry.-vm.zip file. That if you unzip it, or you don't have that? Somebody has the idea. Yes.
It's pretty cool.
Yeah.
Thank you.
Oh, check. Okay.
It's okay, right?
Okay. Yeah, sure.
Problem.
So if on a Windows machine you are having trouble starting up the VM, then I believe you need to set a BIOS setting to enable virtualization. If you're on a Mac laptop or a Linux laptop, it should not be a problem.
We choose existing disk or create new disk?
I'm sorry?
Choose existing disk, create yes.
Choose existing. So, well, I'll just, how about I set up the VM again in my virtual box and walk you guys. So what I did was RNC.
I know.
Like,
Well, I like
Linux.
No, it looks like. Yeah.
So at this point, we select the existing virtual hard drive. We'll go to the VM folder.
No, you should figure out a way to get.
The VMDAK files were untarred.
I've been trying.
And we select Pegasus tutorial VM-430 VMDAK as the first image to tag. But then I push this, click on create and it starts. And then we have, the next step is we need to mount the RNAC disk onto the VM. So go to the settings tab,
Look, you sit here and play with
hit the storage,
share the computer.
and you'll see a controller start up. And then add hard disk. It says choose existing disk. And select RNAC.vmdk. And we have it configured. And then you can just click on stuff.
So right now, just setting up.
So I think it's very important to get the VM started up. So if anybody has been not able to start the VM up, please attach your pink note and one of the helpers will be around to help you set. Looks like everybody is onto the screen. So let's log into the VM. The username is tutorial and the password is Pegasus. Well, I'm actually going to split. Yeah. So if you were to go to the Pegasus workflows lessons on the Software Carpentry website, we've already done the introduction through the PowerPoint presentation we did, and we're now going to try and do the first exercise, which is on your right hand side, and the left screen I'm going to be using to do the exercise in the VM itself. So as a first step, what we will do is we will just try to create a very simple 4-node diamond workflow and try to run it through Pegasus in the local VM and give you a flavor of all the commands that you can use. So what the workflow looks like, it takes in a file f.a and gives it to a pre-processed job. The pre-processed job generates two output files named f.p1 and f.p2. We pass it to fine-range jobs, which take these as input, generate one output file each called f.c1 and f.c2. Pass it to analyze job, and finally f.d output file is. So to generate this description, what the users do is they programmatically come up with the description, the Pegasus format. So what I'll be walking you through is how to generate this workflow using our Python API. So if you log in to the VM in the home directory, you will see some files. Yeah. So there you can see that there is a generate_dax.py file, and it's a simple Python script that allows you to generate. Yeah.
No, I need to know.
So when you have to generate a DAX, you essentially have to specify 5 parts. First, you'll have to import our library to generate the input description of the DAX file. Then you will specify the name for the DAX output file, which in this case we retrieve from the arguments. And then we add these 4 jobs that your workflow is composed of. And for each job, we'll specify what's the input file and what is the output file. And finally, we'll add the dependencies between the jobs to generate the diamond graph, which represents the work. So if you were to look at the file generate_dax.py, first we are importing the Python DAX library. So we are importing it from the Pegasus install in the VM. And from there we import this DAX3 namespace to import all the functions which we require to generate the DAX file. For this script, we are taking the name of the output file that will be generated on the command line. So here we are just parsing the command line arguments using sysrb. This is something, yeah.
What this part? So we have to type line by line, or we just?
No. It's already, you don't need to. I'll get you to run it. I'm just walking you through the code. Yeah, so for the exercise here, you'll be running commands. You won't be writing up stuff, but I still want to walk you through what's involved in writing the code. Sir? Yeah. I'm trying to. Yeah. So the thing is, this VM, it does not have a X environment in, so we didn't have the VirtualBox guest editions, and so we can't do that. So the first thing which we do is we need to create a tag object which contains your workflow. So what we are doing here is you're saying diamond a tag diamond. We're creating a tag that will be called a diamond. Then we'll add a pre-processed job. So we're adding a pre-processed job. We initialize the job object, add files to it. Here I'm saying that there is an input file, f.a, that has to be of type. That has to be of type input. We specify that it's generating 2 output files, f.p1 and f.p2. So we are designating those as output. We are saying that the link is output for that file. And then we are optionally specifying certain attributes on the files. So the transfer attribute indicates that whether you want this file to be transferred back to a location which you are interested in. For the purposes of this example, we are only interested in the final output. So we've set the transfer and the register flags to false. Then we go down to the second level of the workflow, and with similar code, we add the 2 fine range jobs And the add arguments function allows you to specify how that job will be invoked when executed. So the general contract which Pegasus provides to your jobs is the directory in which the job is launched will have the input files that you require. And the way Pegasus knows that these are the input files that are required is by you specifying them in the logical files. So that's why in the argument section you notice there are no absolute paths specified. Similarly, we'll add the other find range job and the final analyze job. And here, if you notice, we have set the transfer equal to true for the f.d file. Reason being, that's the output file we are interested in for this example. And finally, we connect these 4 jobs or these 4 job variables together. We add dependencies, construct the underlying tag. So we are specifying each edge in the. Once we have that, we just call the write XML method. It writes the XML, and you don't need to even worry about the XML form. So as an API, it's a fairly simple API to use to describe your workflows programmatically. Let's say you have a parameter sweep, you can just do a for loop, all the jobs, add them, and that's it. Okay. So now let's try and generate this tag. So you need to run this command if. So what I'm doing is I'm calling the script and passing it an argument as to what's the output file I'm interested in. I'm calling it as diamond.dax.
It's really hard to figure out.
Yeah, I'm unable to zoom in. Yeah. It's because
Make the whole screen.
that's the way the virtual machine is. What I will suggest is that the commands that I am running are actually on the Pegasus Workflows lesson website. So if you were to open up the lesson in your we are at this step, and here I can. So we are at the step of generating the tags. The first, yeah. And we have the diamond tags created. So let's look at what this file looks like. So now let's look at the diamond.dax file that you just generated by running the generate dax command. So the dax file is pretty much structured the same way the way you wrote your code, but the output is in XML. So we have the root a tag element where we are saying that the name of this workflow is called a diamond. So we have the name attribute set, and then we have the jobs described. The API automatically assigns unique IDs for the job. So the first job you had added was the pre-process job. It's got ID 0001. Right? Here it's specifying how that job needs to be invoked whenever it's invoked. And we specify the argument string. And these are the command line options that we had specified when we did add arguments to the job. And then we are just specifying what the input and output files for this job is by this uses tag. So the way you think about it is this job uses a file which is of type input, uses a file of type output, means that it's generating that file. And then we have these attributes specifying whether you want these outputs to be transferred or not when the job is. Similarly, we have the find range jobs, the analyze jobs, and then just the edges in the underlying graph. the diamond. So we have that the ID 001, which is the pre-process job, is a parent to the fine range job, like the two fine range jobs. And then we have the final analyze job, which is a child. So the description, it's in XML, but it's a fairly simple, easy to read XML. And there's an API provided which allows you to generate. And Python is not the only API which we provide. Like we provide the DAX API in Java and Perl. So yeah.
So the diamond.dax file, how does it generate the exception?
So we have this generate dax.py, a Python script.
So the name, so the output file was.
Yeah. So the diamond.dax was. Yeah. So what I had done was I had invoked.
So we could have named something else.
Yeah. Anything. Yeah. I'm just calling it diamond.dax because that's consistent with what we have here in the exercise notes. If you want to copy paste later on.
So yeah. Question: where does the correspondence go between? So you have a so essentially what you're doing here is just writing XML.
Yes, that's it. XML, we are describing the workflow in an XML format, programmatic.
How do you, where does the linkage, so there's no direct linkage between, for example, pre-process and, but I'm assuming there's some kind of process job that's within the architecture.
Yeah. So the pre-process job is associated with an executable. But that executable, we don't specify it in the DAX because we want the description to be portable. So let's say you're specifying the recipe of your computation. You want to share it with users. So you share the DAX with you. And then the next step in our exercise is these information catalogs, which tells Pegasus, okay, what executable does the pre-process job maps to? Similarly, like we referred that there's a f.a input file. We'll figure out that where the f.a input file actually resides in this VM by looking up a replica catalog. So I had earlier mentioned that before you run Pegasus now needs to translate this high-level description to your target execution. So it looks up these three catalogs. The VM is already populated and set up with these three catalogs. I'm going to go through each of the catalogs one by one and describe what it does. So the first catalog which we look at is the site catalog. So the site catalog describes what is your target execution environment going to look like. In this case, we're going to run on a local cluster which is running in the VM itself. Let's say if you were trying to run it on HPCC, then we'll have an entry in this catalog to specify the HPCC point also. In this case, we are assuming that we have a personal Condor pool set up. So the VM is running Condor, which is a cluster scheduler similar to PBS. So we have created just a cluster out of the single node which is on your laptop. And then we have a logical separation where we also have a local site, which is the site where you are running Pegasus. So in the site catalog, we will have two sites. One is the Pegasus VM site, where you're going to try and run your jobs on. And one is the local site, which is where Pegasus is installed and where you are running. So that's your user desktop. Your execution site can be HPCC, cloud, any. So let's so if you were to go, so the site catalog again is in a simple XML form, and let's look at the local site entry to figure out what we need to specify. So for any site, you need to specify what directory your jobs can run, right? So in this case, we are specifying a directory of type shared scratch. That what's a directory which is shared across all the worker nodes on the cluster on which you're trying to run. The local site is just your user desktop, so we specified its home tutorial run. That's where if you get your jobs to workflow to run locally on your desktop or on this VM itself, it will run here. We differentiate between different types of directories. So John had mentioned that on HPC there's a scratch directory that's automatically purged, and then there's a staging site which is kept, which lives across job executions. In case of how that maps to Pegasus nomenclature is the staging area which he referred to is what the shared scratch is. That some scratch space shared across the nodes where you can generate some data and it lives till you clean it. The second type of directory which we have specified for the site is local storage. So that's the storage directory or where you want your outputs to be stored. So the concept is you're using Pegasus to run your computations remotely. It will grab the input data, run your computation, and then your computations are generating some outputs which you are interested in. And you want Pegasus to just ship it automatically to a directory on a particular site. Here it's local storage. Then here, so I'll back to the. Similarly, we have another site which is Pegasus VM, which is the execution site which we modeled the VM itself by running Condor local. So it's a Condor pool running on the local host, and this is the site which normally has a lot of cores on it. Again, we are specifying the shared scratch directory. So even though physically both these two logical sites are mapping the same machine or the same VM, we are specifying different directory points. So in this case, we are saying home tutorial work is where your jobs will run when they are launched Pegasus. We are saying how to, and then we specify what's the file server and how to reach that directory space. So on HPCC, there is a gridftp server specified, so you specify gridftp endpoint. Here we are saying that you can ship in the data using secure file copy, doing it over SSH. So the VM is running SSH server, and we just use that to transfer the data, copy it from directly on this VM to the directory which where the workflow is going to execute. And finally, we are specifying Pegasus that this is a Condor pool. The site is a Condor pool, so you generate your descriptions accordingly. For the HPCC site, the way we would describe it, we'll say it's a grid site because we are going to do a remote job submission. And we will make a sample HPCC site catalog also. So we have described what our execution environment is like. We want to run on Pegasus VM. So now it comes back to the question, how do you tell where your executables are installed? So in this case, Pegasus looks up a catalog called the transformation catalog that describes all the executables used by your workflow. So in our Diamond workflow, we have 3 different types of executables. One is a pre-process, the other is find range, and then the final one is analyze. The transformation catalog is a simple text file. It's short form pc.dat, pc.data. And if we were to go through it, what we are specifying here is, so we have a pre-process executable. That's the executable you referred when you were generating the tags for the pre-process log. You're saying that on the site Pegasus VM, it's installed here in the bin directory on your in your home directory. You have to specify what architecture is this executable for. Here it's x86-64, we're running in a 64-bit VM. You specify the Linux, what OS it is for, and what's the type. It's already pre-installed. I had mentioned earlier during the Pegasus overview that you can get Pegasus to stage the executables for you on the fly as the workflow is executed. And that's why you need to specify this architecture, OS, and type values in the transformation catalog. So let's say you had all these executables locally on your desktop. They're statically compiled. You'll just change the type instead of install to static bind. And then you still can run on a remote cluster, but Pegasus will pick the executables from your local site, match it on the OS and the architecture, make sure it's picking up the right one, and then stage it as an input before the job starts out. Similarly, we have bind range and analyze described. So any conceptual questions about site catalog or transformation catalog so far?
So all things come in just one single file.
Yeah. Like you can specify, it's up to you. Like we, transformation catalog, we do specify a database backend also. So you can, like if you're running lots of workflows and sharing, then you can do it. But normally what we've noticed is that the way the users work is they want them to be self-contained. They don't share these catalogs across different type of applications. And in one pipeline, you will have 20, 30 different executables. You just need to generate this catalog once and then run n workflows referring to this catalog.
So about the scale of the catalog and how you wouldn't, when you're establishing and setting up the Pegasus environment,
Yeah.
you have to write catalogs and kind of define all
Yes.
your system could do. So does the Pegasus group provide examples of that? And
Yeah. So on our website,
right.
it's
It's just like, where do we start? If you've got essentially what we want to be able to do is have a
Yeah, so the reason why we skipped out on the steps of creating this catalog was this experience, like time. We didn't want to be spending most of the time generating these catalogs, but we do provide command line clients which can allow you to generate it.
So you know what you're for the
Yeah, so we provide command lines clients. On the Pegasus website in the documentation section, all the catalogs are adequately explained. And I can also tell from experience that even though we've gone to the effort of providing the clients, at least for the transformation catalog and the site catalog, because the format is so simple and the files are so small, people just prefer to take an example, copy, paste, and change the values accordingly. So in practice, that's how they do it. We did do the work to give you the clients, but not many people use it.
So, like, you could just, like Netscape, where all together and then
Yeah. So that
stuff, it would automatically make you.
Yeah. So we've tried to integrate like for domain-specific solutions with higher-level GUIs. But in general, the problem with the GUIs is also the scalability, right? So what you say, like, I can just click and drag. That's good for this diamond workflow. But later on, when we do the RNA-seq workflow, you won't have the patience or the inclination to connect all the edges to, right? Or like the pipeline that you showed me. You don't want to do that every time you run it, right?
Like, yeah.
So like our reasoning is it's better to invest certain programming effort upfront to generate a DAX generator. And what a lot of applications we end up doing, the DAX generator ends up generating the transformation catalog automatically. You can also do that. So we are at the point where we figured out the executables, the site catalog. Now we want to discover where your input file resides. So That's the third type of catalog which Pegasus supports. And this is the catalog which the users use the most. For the purposes of this tutorial, it's a simple file-based catalog which we are using. And again, if you look into the rc.dat file in your home directory, you will see the format is pretty simple. It says the logical identifier f.a, which is what you specified as the input to the pre-processed job in your Diamond workflow. It resides in an input folder in your home directory. And then we have a logical site identifier associated which says it's on the local site. The reason why we require users to specify the site attribute is that it allows Pegasus to reason about if the data is already there on a logical site. So let's say you have these big bank files or FastQ files which you have already transferred to HPCC before. So in your replica catalog, you'll say pool equal to HPCC. And what Pegasus will say is, okay, the input file already exists. It's not in the directory where I want. So instead of doing a true copy, I'll just do a symlink. And that's how we do the RNA-seq pipeline in this VM later on. The files are in the input folder in the RNA-seq disk. But when you run Pegasus, it will only symlink again. So that's the reason why we expect the pool attribute. Now this catalog, it can be a database-based catalog, or it can even be a directory-based thing that you can specify an input directory where all your input files resides. Pegasus will do the directory traversal automatically and figure out the input paths. So you can specify a directory and not even create this replica catalog file for Pegasus. Or you can interface using a JDBC-based database where you specify that, or you can specify regular expressions in here so that you have a well-defined way of organizing your data sets. So you can, even if you have thousands of files, you can come up with a regular expression. Comes with this. You can have a very small and compact replica catalog, but at the same time popular and covering a lot of inputs. So we've talked about all these three catalogs, but we haven't told Pegasus what those catalogs are, where to pick it out. So that's the part where we come to, which is configuring Pegasus. So Pegasus itself is developed in Java, so it uses Java properties files for configuration, which is a simple key equal to value format. So in your home directory, there is a pegasus.conf file. So what we are specifying here is, there is pegasus.catalog.site. It's of type XML. .file is like the path to the file which we are using as a site catalog, the sites.xml file that I showed earlier. Similarly, for the replica catalog, again, we are saying it's of type file and rc.dat. And for transformation catalog, it's a text-based format, multi-line. And here's the path to. So to get started with Pegasus, in terms of configuration, you just need to provide paths to these three catalogs. And if you're using a directory-based replica catalog, then you can specify that. So we are at the point where we can actually submit the workflow to Pegasus and let it run in the VM. So I'll walk you through the Pegasus plan command, which is the main command that allows you to run or plan the workflows. Behind the scenes, what it does is similar to what I showed in the figure earlier. It will create a job, add a job to the workflow to create a remote working directory. The idea is that we don't want your workflows to clobber each other. So what John had mentioned, that he always creates a unique file name, we try to do it for you automatically, and we ensure that all the jobs in a particular workflow run in the same directory. And The reason why we do it is because we are managing it, so we know when to delete the files. We'll then add some data staging nodes, which will SCP the data in to the directory where the jobs are going to execute. Optionally, we can add these cleanup nodes, which will delete the files when they're no longer required. So, once the pre-processed job is run, the input file f.a is not required. So Pegasus can add a cleanup node which will automatically clean that file up. We'll add the data stage of jobs to transfer the data to the final output location. And finally add some registration jobs to register the location back into your replica catalog. So the idea is that you can track your outputs back into the replica catalog so that later on, if you refer to it, you can just refer to the pre-computed output rather than computing everything from scratch. And, we add wrappers to the jobs to collect provenance. But this part is hidden from by virtue of our tools. So in your home directory, there is a plan_dax.show file. That basically takes in one input, which is the input to the DAX file which we had generated earlier, the diamond.dax file. And it runs this Pegasus plan command, the main command to run your work. What the various options are, we're saying the conf, like what is the configuration file for Pegasus? It's the pegasus.conf file. What's the DAX file? We specify -/-dax or -d option. That's the file you are specifying on the command line. You're specifying the directory where you want Pegasus to generate this executable workflow or the workflow that will be executed. So that will be in the submit directory. The post option is disable data reuse. Let's not worry about it for the time being. And the sites is the execution sites where you want your workflow to run. In this case, in a site catalog, we just have the Pegasus VM site as an execution site. So we're specifying one site. And then we are specifying the output option, which says that as the jobs execute, transfer the output files to another site which you have specified. So in this case, we'll transfer the outputs to the local site, to the shared storage directory space. And then no cleanup. In this case, we have disabled cleanup for the time being, so that Pegasus does not automatically clean up the files that are generated as your jobs run.
What are those files?
Those files, like in this case, these are the intermediate files. So if you go to the screen, these are f.b1, b2, f.c1, c2, f.a. Right? So as a user, the way we describe this workflow, we are only interested in this final output file. So the thing is, once the pre-process job finishes, f.a is a candidate for remove. You don't really need to wait till your workflow completes to start cleaning up the files. So this is a pretty useful feature when you run these large-scale genomic pipelines, where you want to be active on preserving the scratch space that you're using.
So Pegasus itself doesn't make any
additional files. No.
This is the only file that you have.
Yeah. So, but again, it depends upon how true you have been when you were specifying the DAX, right? If there were some files your code generates it, you're not tracking it through the DAX, then Pegasus cannot do anything. So now what we can do is we can just run this plan_dax.show file, pass it diamond.dax. And what it says is, it's planned your workflow, so it's generated a workflow description with all the extra nodes added. Now, if you want to run this workflow, run it using this command. There is a submit option that I could have added to Pegasus plan that would have submitted the workflow automatically. But this exercise, we just have it as a two-step process. So on your command line, all you need to do is Pegasus run, then go home, tutorial, submit the directory which you specified, and there is the run one. So we do Pegasus run and the directory where your workflow resides. So this directory is what we call as the submit directory, the directory where your workflow, the executable workflow is described. And all the other Pegasus commands which we are going to do are driven by directories. So let's say if you want to track the status of your workflow, which is running in this directory, Pegasus status, the directory name, and it will tell you the status of the workflow. Let's say your workflow finished and it failed, you want to figure out why it failed. So Pegasus Analyzer, the directory name, will go through our logs and figure it out and tell. So let's submit this workflow. So we submitted the workflow and now the command has given you some more options. What it's saying is that your workflow has been started and it's running from this directory. To monitor the workflow, like to figure out, at what point is your workflow in PBS you do QSub. Pegasus, we are just doing Pegasus status, which will go into this directory and give you the status by looking at the local ponder queue in the VM. And in case you changed your mind and you want to remove the workflow, you can just do Pegasus remove and the directory. So it's a simple directory-driven command. So as a user, you don't really need to worry about what actual file do I need to mention. So, and now if I do Pegasus status, it's showing me that my pre-process job is running. I have 4 unready jobs and some are queued, right? And we have a watch mode where we can say it will keep on just watching this command, run it every 60 seconds. And when the workflow finishes, exit. So, we can see how the workflow is executing. And this is a perfect time for a coffee break. So we can let the workflow run, grab coffee, and then use the other commands. I'll walk you through what happens if something goes wrong, how to debug. But was everybody able to submit the workflow?
Yep.
Thank you. So the last thing which I wanted to walk you guys over was the case where, let's say, things go wrong. How do you debug that? So what I'm going to do is I'm going to abort my current workflow and start a workflow which I know will. So in the bin directory is what we have in the bin directory we have the executables which the paths which we mentioned in the transformation category, right? So what I've done here is I've moved the pre-process executable and moved it to some other thing so that when the workflow fails, the job will fail because it cannot find the pre-process job, right? So let's plan the workflow again. So it's going to be planned into a new directory. Like the first time we were running the workflow, it's out of the run one directory. And then so we wait for workflow to run and for the job to fail. I'm going to do maybe. So while we are waiting for this workflow to run, I just wanted to also go over two things which I briefly mentioned and which will be referred to in the RNAC module also. One was this notion of clustering the short-running jobs together. So why do we want to do this? One of the reasons is like the overhead of running any job on doing a remote submission mechanism is usually 60 seconds long. Because the job gets submitted locally to a queue on your desktop, then it has to go to the remote PBS queue, then wait, and then get scheduled. So let's say even if there was no queuing delay, just this whole step could take an order of 60 seconds or so. So what you should be doing is that in that case, you should be able to cluster these short-running jobs together. So what Pegasus allows you to do is, irrespective of how your workflow is structured, it will cluster the jobs together based on various criteria. So we have various job clustering techniques supported. One is like the level-based job clustering, where jobs on the same level are clustered together into larger chunks. You can do runtime-based clustering where, like in the DAX, you annotate expected runtimes with your job, and then you say that, when a job is actually run on the remote side, this is the runtime which I want. So then it will just do a bin packing and pack the jobs till we hit that runtime. Or as a user, you can specify subgraphs yourself that need to be clustered together. More details about Pegasus clustering can be found in a documentation also, where it walks you through about how the clustering happens. For example, in this case, independent jobs on a level of the workflow is automatically being clustered into a larger job based on the constraints specified by Pegasus. So the other thing which the follow-up module ends up using is data cleanup. In case of large workflows, users run out of disk space, which is very often the case in case of bio workflows. And why does it occur? It's because workflows bring in huge amounts of data. Some data is generated during workflow execution. So if you're not cleaning up as the workflow is running, then you're eventually going to run out of scratch space and all your pipelines are going to reach to a halt. Pegasus does an automatic analysis of the underlying graph and figures out the optimum place where to add these data cleanup nodes, which just removes the files from the scratch file space when they are no longer required. And we are actually running a bit short of time, so I'm unable to get my workflow finished here. So we'll have to keep it at that and sort of carry over to the next exercise. But I'll take any questions. Yeah.
Yeah, we have Pegasus workflows inside another one.
Yeah. So that's what this tutorial did not go into details, but that's what we call as hierarchical workflows, where a node in the workflow can refer to another.
That workflow as a one job with one instance and several others.
Yeah, and then that node itself. So you use the right term. It's a recursive work that is run.
Yeah. When you're working with biologists or some domain scientists who aren't necessarily so computationally savvy, what are the main kind of things that like? Is it the format of the files or the execution of the files?
So I think so
data model. What is it?
there are a couple of things. Like first of all, there's a tendency to use shell scripts but not do strict enough error checking. So very often we run into the cases where our new users give us some shell scripts they have been running. They have not taken care of the simple cases where, like, if there's an error, you need to exit with a non-zero exit status. So that's something. The other thing which sort of also our experience has indicated is the users don't really like going through the log files themselves. That's why we've invested a lot of effort in building these tools which run out of a submit directory, which can analyze the workflow, give you the state. They don't like going through like Condor logs, figuring it out themselves. That's something which we realized over the years, and we've put a lot of effort in the past couple of years to build tools on. But other than that, initial hand-holding and we are able to get them one workflow specified and running with the DAX generator. A lot of users just run with it. Like we have a postdoc in UCLA who's run like 15, 20 different types of workflows just by himself. And we just helped him once over an afternoon at ISM.